This step details the construction of a model designed to predict when the primary model will make errors. This error predictor employs Bayesian methods to quantify the uncertainty in its predictions. The goal is to identify which features are most indicative of potential errors in the main model's performance. Prepare the dataset for training the error predictor by including the original model's training data, error features, and binary error labels which indicate whether the original model correctly classified each instance, with 0 representing a correct classification and 1 representing an incorrect classification. This refers to the dataset used to train the initial machine learning model that is being analyzed. These are the features engineered to represent the hypotheses about the causes of errors. For example, blurriness score for images or sentence length for text. These labels indicate whether the original model correctly, 0, or incorrectly, 1, classified each instance in the dataset. This forms the target variable for the error predictor model. The training data, error features, and binary error labels are combined into a single dataset. This dataset is used to train the Bayesian error predictor. Select a Bayesian model suitable for predicting errors. This is a Bayesian approach to logistic regression, suitable for binary classification problems like predicting errors. It places prior distributions on the model's weights. This type of neural network uses Bayesian inference, providing uncertainty estimation in its predictions, which can be valuable for assessing the confidence in error predictions. This is a non-parametric Bayesian model useful for classification, especially when dealing with complex, nonlinear relationships between features and error patterns. This involves specifying prior distributions for the parameters of the chosen Bayesian model. For example, assigning weakly informative priors to error features, indicating an initial assumption that no single feature is overwhelmingly important. Training the Bayesian model involves inferring the posterior distribution over the model's parameters using techniques like Markov chain Monte Carlo, MCMC, particularly Hamiltonian Monte Carlo. The trained Bayesian error predictor outputs a probability that the original model will make an error on a given instance. This probability reflects the confidence that the original model will be wrong, given the instance's features and the prior beliefs.